We will continue with the transport network data analysis, um, and this is a time series data of public network transport around Auckland region. So in the previous lab we looked at the interpolation methods of linear kind and cubic kind, and we also compared it with the forward fill method and the backward fill method, and we found out that the linear method was most suitable with less mean squared error, least error of precision, lowest error of precision, which was about 0.13. So yeah, so in this graph, which we have limited the horizontal axis values, shows that the linear fill method is the best method. And in this lab, we will apply KNN mean method to find the missing values. Now, how we do that is, so we will create a definition KNN underscore mean of TS comma N. Now this TS is the missing dot value dot values, and let out equal np dot copy of the TS for I comma value in enumerate of TS. If np dot is nan of value, then np dot is nan of value, which means that if the value is a nan value, which is a missing value, then let n by 2 equal np dot ceiling of n divided by 2. Let lower equal np dot max of 0 comma int I minus n by 2. Let upper equal np dot mean of length of TS plus 1 comma int of I plus n by 2. Let TS near equal np dot concatenate of TS from lower to I comma TS from I to upper. Let out of I equal np dot nan mean of TS near, retain out. So we will show this definition, these functions separately, what happens. So let's go up here. So let out equal np dot copy of missing dot value dot values. So what it does is that in the missing data frame, let's show that. So this is the missing data frame, and in that there is a column called value, and that value column, if I just have that column value output, then looking at only the values, that gives in array form. So we're letting out equal np dot copy of missing dot value dot values, printing out text array. For I comma var in enumerate of missing dot value dot values, if I print I comma var, that prints the index number and the value. So index 0 gives 4.0834. Let's check that. Yes. And index 1 is 4.193. And index 2 is 4.3803. So these are all the this command over here. This gives the index number and then the value. Then for I, val in enumerate of missing dot value dot values, if np dot is name of value, then print I, val. So for example, index 5 is name. So this should print index 5 nan, index 15 nan, index 16 nan, index 24 nan, index 25 nan, index 26 nan. So let's have a look. Yes, so this function does that. Okay, let's check the other command. N by 2 equal np dot ceiling of 8 divided by 2. So let n by 2 equal np dot ceiling of 8 divided by 2. This is a KNN method. So it chooses the n number of nearest neighbors and then it takes the mean of those n number of nearest neighbors. So in this case, we are taking 8 neighbors, 8 nearest neighbors, and then we will find the KNN mean. So np dot ceiling of 8 divided by 2 is 4. Length of missing values plus 1 is 177. Okay, next command. For I, val in enumerate of missing dot value dot values, if np dot is nan of value, so which means if the value is the nan value, then lower equal np dot max of 0, int I minus n by 2. So if the value is nan, then that particular index value, we subtract the n by 2 value, we subtract 4 and we take the maximum of 0 and that value. Let upper equal np dot mean, that means minimum of length of missing dot values plus 1, which is 177, comma int of I plus n by 2. So index I plus 4. So we are looking at the minimum of missing 177 and I plus 4. So print I, lower, upper, missing dot values, bracket lower to I, missing dot values of bracket I to upper. Let's see what it gives. So index is 5. So we know that index 5 has a nan value. So index is 5 and lower is 1. So 5 minus 4 is 1 and np dot max of 0 and 1 is 1 and upper is 9. So np dot minimum of 177, and 5 plus 4, which is 9, is 9. And so missing value dot values lower to I. So 1 to 5, these are the values, and 5 to 9, these are the values. So 5 to 9, so if you look at the index value 5 to 9, this it takes the values from 4, 5, 6, 7, 8. It doesn't take the value for 9. Then for I comma var in enumerate of missing dot values, if numpy dot is name of value, then lava equal np dot max of 0 to int I minus 4, and upper equal np dot mean of 177 and int I plus 4. Print np dot concatenate missing dot values from lower to I, and missing dot values from I to upper. So it gives this. So it prints the 8 nearest neighbors. So this is index number 1. So lower to I 1 to 5, that won't count 5, but it will count 1. So 4.9123 is for index 1. Let's have a look. Yes. So the two arrays are concatenated, and it forms the 8 values in each array. And then in this piece of loop, for I comma var in enumerate of missing dot values, if numpy dot isName val, which means if the value is name missing value, then lower equal np dot max of 0 comma int of I minus 4, and upper equal np dot mean of length of 177 comma int of I plus 4. Let ts underscore near equal np dot concatenate of missing dot values of lower to I, comma missing dot values I to upper. Print ts near, comma np dot name mean of ts near. So np dot name mean, which means that if there is a missing value, then we avoid that. So here what happens is that these values, there is one missing value in this array, so the 7 values are added and divided by 7 to get this. Now so for the fetched array, we check that the missing values, so missing values is not counted, so the 7 non-missing values are added and then divided by 7. Let's check for second array. There were 2 missing values, so let's add these. We don't want names, and then we'll put this in bracket, and there are 6 values divided by 6, and this gives 4.1996666 and so on. And we can see that this loop also gives np.nen mean of TS near gives that value as well. Now for I comma val in enumerate of missing dot value dot values, let out equal missing dot value dot values dot copy open and close bracket, print bracket out I if np dot is name of value, if the value is missing, then lower equal np dot max of 0 and int of I minus 4, upper equal np dot mean of 177 and int I plus 4. Let ts near equal np dot concatenate of missing dot value dot values of lower to I, comma missing dot value dot values of I to upper. Let out of I equal np dot nen mean of ts near. Print out I. So we printed the out I very first time, and then we printed the out I if np the value is a nen value. So you can see the values are printed, values are printed until we have nen, and when we have nen, then this loop, if loop, does its commands and prints the value. And in the second one, they were the value kept on reading read, and when there is a missing value, then the value is calculated. And then the next reading was also a nen value, so the value is created, and then the values are read until there is a missing value, and then the missing value is calculated, and so on. So our definition, let's create the definition. So we call the definition instead of carrying out this whole loop function, we will just call the definition. So let def KNN underscore mean of missing dot values comma 8. So these are the inputs. For I comma val in enumerate of missing dot value dot values, let out equal missing dot value dot values dot copy opening close bracket. If np dot is nen of value, let lower equal np dot max of 0 and int I minus 4. Let upper equal np dot mean of 177 and I plus 4. Let TS near equal NP dot concatenate of missing dot value dot values lower dot I missing dot value dot values I dot I to upper. Let out of I equal NP dot NN mean of TS near retain out. So fill missing values. So what happens is that, so this definition is over here. So we are going to plot the graph. Missing, let missing of new column KNN mean equal KNN mean of missing dot value dot values comma 8. So we are calling the definition. Let error equal NP dot round of mean underscore squared underscore error of complete value comma missing of this new column KNN mean comma 2. So we are rounding the error to 2 decimal place. Missing of KNN mean, which is the new column, dot plot of label equal KNN mean M bracket MSC colon plus HDR of error plus comma x equal axis. So it will print the graph on the same pair of axes. Color equal tomato, alpha equal 0.5, style equal dot dash. So access dot legend open and close bracket, access dot set underscore title of filling the missing values with various methods, plt dot show open and close bracket. So let's run this. So we are comparing all the previous graphs with the KNN mean graph, and KNN mean graph, the color is tomato, that is very light red. So let's have a look. So these light reds show the values calculated using a KNN mean, and the error of precision is 0.22. Now let's set the axis limit, the horizontal x limit, and then rerun the graph commands. Axis dot set underscore x limit of from 2009 December 1st of December 2009 to 1st of February 2011. Let's run that. So you can see the month year is from 2009, 1st of December 2009 to 1st of February 2011, and you can see that this KNN mean graph, now this very dark red graph is for backward fill, and this black graph is for cubic fill, and this blue graph is for forward fill, and this light red, this is tomato color, this is for KNN mean, and this dark red is for the backward fill, and this red one here is the available data, and this orange graph is for linear fill. So which shows that this red graph, which is for backward fill, is overtaking, but only place where KNN mean and all those comes in, the values comes in around backward fill values is this range over here. And the error of precision is not very good as well. The linear fill gives the best fit, which is 0.13. The mean square error is the lowest. Let's decrease the size of this plot. So width is 10, that's okay, but let's decrease it to 5. So now we can see better. Yeah, so only place when all the other values are very close to this backward fill is in this range here. July, October, June to October 2010. Okay, so we will continue with the lab in the next video.